Welcome to AI Podcast. I'm Mark, and today we're digging into a new tertiary AI paper called ScriptSmith.
And I'm Elena. Quick headline first. ScriptSmith is a practical framework that helps SRE and IT ops teams turn plain English fixes into bash scripts, check those scripts without actually running them, and then refine them. Net effect, a modest but real bump in correctness, plus a safer workflow.
Exactly. The work is led by Pooja Aggarwal and Oishik Chatterjee from IBM, with colleagues across IBM Research and IBM Software. Now, why this matters, a lot of incident remediation still lives in bash, but validating a shell script is messy, because the right answer often depends on the machine it runs on.
Right, if I say, show me free memory, the output changes minute to minute. And in production, you might not even have a safe sandbox to test in.
That's the core pain. Traditional code benchmarks assume you can run the code and check a unit test. ScriptSmith flips that. It treats correctness more like a code review than a test run.
So how do they review a script without running it?
Think of it as a careful read-through. They use a method inspired by CodeSift. The system reads the task description, reads the generated script, and asks, do these two stories line up? It does a similarity pass, a difference pass, then combines those signals to decide if the script is functionally on target. If it's off, the model explains why and tries again.
Like a colleague saying, hey, your find command grabs file names, but the task asked for paths. Then you fix the flag.
Exactly. And ScriptSmith is bigger than a single pass. The loop is retrieve, generate, assess, refine. First, it tries to retrieve a known good script from a growing catalog. If that fails, it generates a fresh one, evaluates it without execution, and only then refines if needed.
That catalog piece is underrated. SREs already have piles of known good snippets in wikis or runbooks. ScriptSmith turns that into a searchable memory so you don't reinvent the wheel every incident.
And when an SRE approves or edits a script, it goes back into the catalog, so the system keeps learning what good looks like in that environment.
Okay, what did they test this on?
Two public bash benchmarks that ops folks will recognize: CodeSift and Intercode. CodeSift has a stable testbed, while Intercode's execution environment was less reliable, so they leaned on expert judgment there. They also ran a user study with domain experts labeling whether the first pass and the refined pass were correct.
Which models did they use?
A mix: open models like Llama 3 in smaller and larger sizes, and closed models like Gemini 1.5. The interesting bit isn't just which model wins, it's how they organize the roles.
You mean the peer review idea?
Yes, self-review is when the same model that writes the script grades it. Peer review is when a different model does the grading. The authors found peer review works better. It reduces self-bias and actually improves the downstream refinement, because the grader catches more genuine issues.
That makes intuitive sense. It's the rubber duck effect with a twist, a different duck. Also, assessment burns a lot of tokens, so they often put a smaller model in the grader seat, then bring in the heavy hitter only when it's time to refine a subset of tricky cases.
Exactly. That's the cost-accuracy trade. Use smaller, cheaper models to sift, then spend on the bigger model where it matters.
So results in plain English?
Overall, ScriptSmith lifts script quality by around 7 to 10%. And there's a standout configuration where they kept a small model for generation and assessment, but used a larger model just for refinement. And that produced a best-case jump of roughly 17% on one dataset.
That's not flashy marketing math, but if you're on call at 3 a.m., a steady single-digit bump can be the difference between paging a teammate and closing the incident.
Totally, another nuance. On Intercode, execution-based checks sometimes disagreed with human experts over picky output rules, like printing an IP with extra text. That's one reason the paper argues for expert judgment and reference-less evaluation in ops scripts.
Right, because works in the real world and matches an exact string the grader expects aren't always the same thing.
And they actually deployed this as a tech preview inside IBM Instana's intelligent remediation pipeline. So, not just a lab demo, the pipeline ingests events, recommends actions, and ScriptSmith proposes scripts. An SRE can accept, tweak, or reject, and that feedback updates the catalog.
I like that human in the loop part. It's more like a safety rail than an autopilot. And I can picture the workflow. The system offers a script, the SRE spots a risky RM flag, fixes it, and now that safer version becomes the new default.
Exactly. Now let's pressure test it. What should listeners be cautious about?
A few things. First, sample sizes are on the modest side, and in one case, a stronger model was only evaluated on a subset. Second, textual evaluation is clever but not perfect. It can miss subtle quoting or environment quirks that only show up at runtime.
And they call that out. There were even cases where asking the model to explain errors nudged it into overthinking and breaking a previously correct script. So you want guardrails like don't fix what isn't broken.
Reproducibility is another point. The integration, prompts, and the curated script catalog are what make this sing. If you try to replicate without those ingredients, you might not see the same gains.
On the plus side, the paper's design choices generalize. Retrieval first, then generation, then execution-free assessment, then targeted refinement. It's a sensible assembly line for ops code.
Can we give a concrete example so people can picture it?
Sure. Imagine the task says, find files accessed in the last hour under a workspace folder. A naive script uses the wrong time flag. The assessor flags it. The model explains, you used access time in minutes, but you need modified time in minutes. And the refine step swaps the flag. No Docker, no unit tests, just a thoughtful read and a quick fix.
And a second example, copy everything with foobar in the path, not just the name. The initial script checks names, the critique says switch from name to path, the refined script does exactly that. That's the flavor of improvement we're talking about.
Future work?
A couple directions. Extend beyond Bash to PowerShell and maybe even infrastructure formats like YAML. Blend textual checks with lightweight static analyzers so you catch quoting and edge case flags. And measure operational metrics like mean time to resolve and review time saved, not just benchmark accuracy.
Plus, more openness would help. Publishing prompts, assessment templates, and sanitized snippets would make it easier for others to reproduce or improve on the results.
All right, big picture takeaway?
ScriptSmith shows that a careful, execution-free assess and refine loop can make shell scripts more reliable without spinning up fragile testbeds.
And if you're building something similar, borrow their playbook. Retrieve before you generate, have a different model do the grading, and spend your largest model where it counts, in refinement. Keep a human in the loop, and let the catalog learn over time.
That's it for today's AI podcast. If you're an SRE leader or platform engineer, this is one to watch, especially if your incident playbooks are still living in scattered wikis.
Thanks for listening. If you've got papers you want us to unpack, send them our way. See you next time.